Welcome to the OutSystems Security in the OutSystems Platform Masterclass. In this masterclass, we'll be covering what is security, why security, an introduction, some built-in features of the platform to cover security, applying those features, and some additional tips. So, what is security? Well, security is different things for different people. For the user, it can be something as vague as unauthorized people can't see or do things that they shouldn't, and the application works as expected. Now, this is extremely vague, obviously, but the IT professional needs to be able to convert this into terms and actual code that we can apply in our development and applies these protections for the user. This means the IT professional should be able to identify who are the people, which we in the IT world identify as users, and what is it that they can see or do, which can be display information or actions that react to user requests, and all those need to be protected using roles, as we'll see later on. The application should also work as expected, not necessarily in terms of unintended bugs, but in terms of unintended secondary information or information leakage. Say, for instance, you have an email application and you're sending a sensitive message, a sensitive email to a manager. Now, you expect that as long as you only type that manager's email on the application, only that manager will receive your email message, and not some third party such as a hacker, a journalist, or somebody else. So in this sense, the application should work as expected. Now, these vague concepts for the user, for the IT professional, mean access control, data access, privacy, reliability, and trust. In fact, MIT defines IT security as being about protecting the integrity, accessibility, and reliability of electronic information. For the sysadmin, who is an IT professional, security can mean network segmentation, intrusion monitoring, authentication mechanisms, data transport encryption, application backup, and application availability monitoring. For developer, it can mean checking user permissions as required, validating input data, escaping output data, encrypting data being input and output from your system, and debugging and exception catching and logging. Now, OutSystems takes care of security in most situations. However, the sysadmin and developer should not circumvent OutSystems protections. It's possible to circumvent these protections in some circumstances to allow the platform to be more flexible in some edge use cases where you want to do something very, very specific. OutSystems cannot determine your access control requirements though, so you need to define them manually. And once you start going into security a bit deeper, you will understand that no platform, of course, can understand all of your requirements, and you need to implement the proper mechanisms for enforcing the proper security policies of your enterprise or of your customer using specific code. So security is everyone's responsibility. Now, it's up to the sysadmin to secure the systems, and it's up to the developer to build secure apps. Let's take a look at a specific case study, a very simple case study, which we'll be addressing during this masterclass. Now, we have a single corporate environment of a customer who wants to have a website app. This will require no login, obviously. The customer also wants a partner portal app where partners should log in with their username and password. And finally, an intranet portal app for its employees who should also log in and use integrated authentication. Now this is the diagram for such a layout. Here we have the OutSystems environment where the customer's applications are running. Here his employees or corporate users are accessing the applications from the internal network. And both partners and internet users are accessing also some applications here. Now, internet users should be using the public website and partners should be using the partner portal. So this is the URL for the public website, which is the most common URL for the vast majority of websites. Then you have a specific partner portal application which partners can access, and the intranet application for your corporate users. Currently, there is no network segmentation. And therefore, this initial layout has several problems. And to understand the problems, let's first meet Joe Hacker. Joe Hacker is trying to show off his skills. If the opportunity presents itself, he will try to have financial gain of those skills by selling information. This is also called espionage. Selling damage. This is called sabotage. And even moving funds. This is in a very specific case of trying to attack a bank. So the problems of the current case study is that Joe Hacker can access any application by typing its name, the application name. Say for instance the partner portal or the internet. Even though we've seen that it is the intention of our customer to have specific logins for these applications, currently we haven't yet set this up. Joe Hacker has even access to back office and system applications such as Service Center. And all users access the same screens and execute the same actions. And this is because there is no login. All the screens are by default anonymous, and apparently the developers haven't yet had the time to change such roles to something else. So what does the OutSystems platform offer to help securing your apps? First of all, HTTPS, also called SSL or TLS, which provides for private communication between the server or the environment and the browser that's accessing those applications. Integrated authentication, which will allow you to log in onto the applications without even needing to type any user or password. Selective deployment. This will allow you to place specific applications onto specific front-end servers, which you can then place on specific domain addresses and thereby protect them using firewall rules. Code injection prevention. This prevents hackers from actually accessing and damaging your internal structures such as entities or displaying on your applications data which is actually false, is being inserted by the actual hacker. Data encryption, which beyond this mechanism here, which uses encryption to provide privacy between the server and the client, the environment and the browser. Data encryption allows you to secure, hide by making impossible to understand some information which you may be storing on a database, on a file, or even transmitting to third parties. You can have custom data encryption. Internal network specification, which allows you to state which are the IP addresses defined for your local premises systems, and thereby only allow some screens and some applications to be accessed from the internal network. And finally, roles, which allow you to state who are the groups of people who can access your screens. Let us begin by looking at the first of these features. We're going to take a look at each of them in turn. Let us start with HTTPS, which stands for HTTP secured, which means that is HTTP, whereby we're using one of these protocols, SSL or TLS, to secure, to encrypt the communication. Currently, the protocol that's offered and implemented by OutSystems is TLS, as SSL has shown some vulnerabilities and is now deprecated. However, it is the name that most people understand and know, which is why it's still shown here on documentation. This is secure socket layer, and this is transport layer security. They both mean the same thing in terms of technology, the underlying encryption of communication of the HTTP channel. So without HTTPS, when Peter Mann is accessing the server where the OutSystems platform is being hosted, the browser performs a so-called GET request, and the reply from the server will include a session cookie. This session cookie identifies a session. It's a time span during which the same person is accessing an application. This is a session, a bit like a movie session. A movie is composed of several scenes, a car chase scene, a romantic scene, and so forth. And the movie plays different times a day, but there is a coherent sequence of those scenes from beginning to the end of the movie. During the session that plays at 10 a.m., there is then again another session of coherent sequences that plays at 2 p.m. and so forth. So a session describes a sequence of coherent and usually time-limited accesses from a browser, so that the applications understand the user did this and now the user wants that, and so forth, and can therefore react to user requests. So the server responds with a session cookie, a number which identifies the current session. So the browser from that request onwards, every time it requests something from the server, will include that session cookie, which is a long number, maybe with a sequence of characters. Something much more complex than this sample here. Now, the problem here is, even if the user has logged in, and this was the example that is shown here, the session identifies the user, not only the browser, but also the user. So let's continue playing what the user is doing. He's making further requests to the server, he's pushing buttons, he's navigating screens, and these are translated onto requests, and the browser is always sending the session cookie, and the server understands, after the user has logged in, that this session has a logged in user which has some permissions, some things which he is authorized to see and do in the application. Now the problem here is that if our friend Joe Hacker has managed to penetrate a network company that happens to be a network company that you use on your company, or that Peter Mann uses to connect to the internet, or something in between, then he can see all traffic that's traveling, and he can see this traffic here. All requests done by Peterman over to the server. Without HTTPS, he can see them in plain text. Plain text is the expression we use in IT to refer to something that's not encrypted, regardless of whether that's text actually, or even graphics, images, sound, video, and so forth. He can see these requests traveling in plain text. He can therefore see the code that's being used for the session cookie. And he can therefore replay that code himself on his computer. He can repeat the same requests to the server, sending the exact same session cookie, and therefore the server will think that he is also Peterman. Now, of course, the question becomes, why doesn't the server use an IP? This would identify Peterman's computer as the session rather than the hacker's IP as being the holder of the session. But there are multiple reasons for this, and this is not the topic for this masterclass, but some of them are that an entire company can share the same IP. There is a technology called NAT, which is very, very old. This is Network Address Translation. It was created because the number of IP version 4 numbers was being exhausted, running out worldwide, and something needed to be done, and this mitigated the problem for many, many years. And only recently have these numbers been exhausted on a top level from the major distributors, and they're slowly being exhausted over the smaller distributors. And of course, there's a replacement protocol that's been around for many, many years as well, which is IP protocol version 6, and this completely solves the number of IP problems. But this is still available on many, many computers. Some of them and some internet systems are so old they don't understand IP version 6, and therefore compatibility is required. And service providers often charge for fixed IPs. So if you're connecting to the internet, nowadays you don't have a temporary connection. On the old days of phone dial-up connections, you would make a phone call to your provider, and of course, because you were paying for this call, you would often, or in most countries, you're paying for this call, you would make a time restricted connection to the internet. So you'd be connected for 2 hours, connected for 5 hours, but you would then disconnect. So during your connection, you could have an IP number, which was your own, but then you would lose that number. Nowadays, internet connections don't work this way. Residential internet connections. They are permanent connections, they are cable connections, fiber connections, they are always on connections, and operators can't let you have the same IP number while you're connected. Some of them rotate your IP number, or when they see there's no traffic coming from your home, they disable your IP number to reassign it to some other people. Again, because IP numbers, the old IP version 4 numbers, are a scarce commodity, so they're expensive. They charge you to have a fixed IP number, which is another reason why they sometimes change and rotate IP numbers for customers so that they don't try to use theirs as being permanent in any fashion. And this means that while you're using the internet, your IP number can even change. So servers can't identify you by your IP number, and this is why the technology by the web development community at large, not only by OutSystems, is to use a session cookie to identify your session, to identify that you are the same person that just 5 seconds ago accessed the screen and is now pushing a button, so that there's some context. And the name has something in common with something on the platform, which are session variables. Let's take a quick look here in data. we have our session variables. These are variables which hold their value as long as the user keeps doing requests with the same session cookie. And if the cookie is different, they lose their value, they're reset again. This is another meaning of session that has some visibility to the developer. So servers can't use the IP to identify your session. They need to use the cookie. So the hacker can steal the cookie. How can we prevent this? How can we prevent that the cookie is stolen so that the hacker can do the so-called replay attacks, where they simply show the same credentials to the server and the server thinks they're Peter Mann? Well, by using HTTPS. This is the encryption of the channel. When should you be using this? Well, if your app requires a login or displays sensitive data, this is the first thing, the main thing that makes you want to have HTTPS. Why? Because HTTPS encrypts the channel, as you're going to see on the next slide, and whoever tries to listen in won't understand what's being transmitted. So the user's password, which is extremely sensitive information, is not seen by somebody who is eavesdropping on the connection. In order for this to work, you should activate it on all such web screens and web services, those that have logins or that display sensitive data. However, it's not enough to only encrypt the login page. There are many occasions where you're actually displaying sensitive data, you don't even realize it, and we've just shown you an example where the hacker, just by looking at any request done to the server, can look at the session cookie and use it to replay the session information on whichever request that he wants to, thereby impersonating Peter Mann. So now with HTTPS, when Peter Mann tries to log in, he does a GET request, but the server tells him, oh, come over to this site, redirect to HTTPS. And that is what the browser does automatically. It now does a request to HTTPS, and this arrow is now green because it's safe. The data is encrypted. The server replies with login page content. The user replies with the username and password that he typed. This content is encrypted. The server replies with the encrypted session cookie, and all requests from now on include that cookie, but they are secure, they are safe, they are private between Peter Mann and the server. So now, because these requests are private, our friend Joe Hacker, even though he can still see what is going on traveling between the browser and the server, he can only see the encrypted version of this, not the plain text. And encrypted means that it's gibberish, it's garbage for Joe Hacker. He can't understand the data. It's not that he can't see it, he can see it, but he doesn't understand it, and he doesn't have the required keys to decode this information. Let's move on to another OutSystems feature, which is integrated authentication. An untyped password is one less way for an attacker to get in. Now, this is absolutely true. If you are used to typing your username and password on multiple systems, you eventually become desensitized as to which systems actually require your username and password. And whenever one of those screens pops up, you simply type in your username and password and move on. This means that a hacker somehow manages to compromise one of your applications or it simply send you a phishing email. This is spelled with PH, phishing, and it's the name given for emails that are trying to acquire sensitive information, typically access information such as passwords for systems. Can be private systems such as Facebook, LinkedIn. It can be bank systems, or it can be corporate systems. Hackers will find out who works at some companies. They will get email addresses of those people. They will find names of those people. They will find examples of emails that those people send. And once they have all that information, they can impersonate, mimic one of the typical emails that people send from one to the other inside your corporation using names that you guys have in your own corporation that will make the reader feel like it's a real email. And they'll say something like, oh, could you please go here and do this or that? And you click on the link. You don't even realize that the link is actually not the link of one of your internal applications. But again, if the hacker knows what is the look and feel of your login page, it just displays that look and feel. And if you're accustomed to typing it in, you will type in your username and password. The hacker can't verify this, of course, so it just says, it makes the system say, oh, I'm afraid you made a mistake on your password. Could you try again? And either he leaves people on his own system. They tried 3 or 4 times, it doesn't work. They eventually give up and close the browser. I don't think of it again. Or the hacker, if he knows the real address, once he has the username and password, he will say, I'm afraid there was an error. Could you try again? And when the user clicks here to try again, he will redirect the user to the real application where the user types again his user password and he succeeds. So from the point of view of the user, this was simply a mistyped password. But actually, it was a fake application trying to find and store your username and password. And now the hacker has your username and password. So if your users are accustomed to typing usernames and passwords everywhere, they don't even realize it when one of these things happens. And if you manage to remove this difficulty, to remove this extra step of logging in to your applications by somehow this being automatic, then users are accustomed to things just working. And if suddenly one application doesn't work and asks for username and password, as long as they've been educated that this is a common way for hackers to get username and passwords, they will stop and think, this is odd. And hopefully, very, very quickly, either the first user that this happens to in your corporation or the second or the third, report this to IT, and IT can take measures to block those emails. So how do we do this? How do we log in users automatically? Well, we do that with integrated authentication. This is a system that is provided especially by Internet Explorer that when accessing other Microsoft systems, namely Internet Information Services, which is the base web server used by all systems on the .NET stack, the browser, Internet Explorer, can talk to the underlying server, understand that the server is local, and provide some credentials, not the username and password. There are some different things that technically are passed over to the server. For security reasons, operating systems don't provide their applications, including the browser, with the user's username and password. So what is passed over to the server is something slightly different. It's usually called a token. Again, it's a number of the current logged in user. So the browser sends in information that basically kind of describes who is currently logged in. The server checks that information against the central directory that has that information. And if that information is verified, nothing else is required. The user is logged in on the web application. OutSystem supports this in what is called integrated authentication. And if activated, then those screens can be accessed automatically by whoever can be automatically authenticated on the web server. And you can set this on your interface, on your flows, such as here. We have integrated authentication. You set it to yes, if you wish. And on each of your screens, you can also set this to yes on each individual screen that you want protected with integrated authentication. You can also see here the previous protection method, which was HTTP security. It is right here, and you can set it, of course, to yes, or actually define it as SSL TLS to have that screen protected with SSL. Integrated authentication is just a no yes option. Flows can be protected, again, using these parameters here, and integrated authentication right here. And this is integrated authentication. Not only is it better in terms of usability, all users will applaud and love you because you have removed one more barrier for them to do their work. They no longer need to log in manually on their applications. They really don't care about security. They just want to do their work. But this will also be better in terms of security because they will no longer be desensitized to login screens. Now the next feature is code injection. Now, without code injection prevention, you would get what is here shown on this cartoon. This is a common cartoon that's been going around the internet that describes, illustrates code injection. So here, mom is calling school. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way, did you really name your son Robert, end quote, close parenthesis, semicolon, drop table students, semicolon, dash dash? Oh yes, little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs. And this is a short cartoon that really describes the dangers of not preventing code injection. And this is an obvious example. If one of your forms has this kind of thing typed in, and you're inserting it blindly on a SQL, actually on an update statement, or even a SQL statement, a generic SQL select statement, then note that the string that you're trying to insert is closed here. This syntax ends the previous statement successfully, and then asks SQL to have another statement, which is to drop the tables. So this is real, and this will happen if you don't protect against code injection. Now, the OutSystems platform protects this automatically. And you don't need to worry about this except in certain circumstances. Any text input that's used to build code is susceptible to code injection. Not only text inputs from the user, but really everything that comes from the browser, even things that you think you've calculated in JavaScript, that you've retrieved from browser properties in JavaScript and sent over to the server, a hacker can can mimic your requests, but change the data that you so carefully calculated in JavaScript to anything else that the hacker wants. So anything coming from the browser is not to be trusted. And this includes things that come from the external network in general, anything that you retrieve from external web services, calls made into your web services, and so on. Anything external to your servers is actually not to be trusted in terms of code injection. The OutSystems platform, by default, already prevents code injection at several levels. Where is it still possible? Well, when you open up that possibility. You have screen unescaped expressions, and in those you need to explicitly set the expression to being unescaped, because by default it's escaped, which means it's protected against injection. Expand inline query parameters. Again, query parameters of an advanced query by default are not set to expand inline. You need to explicitly set them to expand inline in order for them to be an issue. And manually built URLs. And these, of course, are the ones that you don't actually drag actual screen addresses to your buttons, to your links. You don't define the destination as being a screen or a URL that you just copy and paste from one place to the other. If you are actually manually building them in an expression, then you need to take some care as to how you're doing that. So how can we safeguard against those spots where we are asking the platform to give us specific access to features which can become problems? Well, if you have an unescaped expression, you should use encode HTML or encode JavaScript around strings that come from external sources that are being inserted into your expression, either in a place which is HTML or in a place that is supposed to be a JavaScript string. You can safeguard against manually built URLs if you're building them by placing around a string that comes from an external source encode URL. You would use this around a component of your URL. And finally, if you need to use expand inline parameters, you would safeguard against SQL injection by using around a string that comes from an external source encode SQL. Now let's take a quick look at where we find those things. On an interface, if you drag an expression onto your interface, say here, by default, as you can see, we have escape content yes. If you set it to no, then the value you have here is supposed to be HTML, such as bold. This is bold /b. Now this would be something that's not escaped, which means that it's simply copied as is onto the screen's output. And the screen's output to the browser is always HTML. So this is supposed to be HTML. Now, if this string came from an external source, you would go out of the actual string and use escape HTML. I'm going to hit Control Space. Sorry, it's encode, not escape. Encode HTML. Here we go. Encode HTML and your string. And here we go. This is how you would do it. This way, this string is encoded. So if this string includes HTML tags, they are not interpreted by the browser as tags, because special symbols in HTML, such as the less than and greater than symbol and the ampersand, which is this one, this one here, these symbols are encoded in special sequences which represent those characters themselves rather than have the browser interpret them as HTML code. The same thing happens if you have a JavaScript code, a string with JavaScript code here. You can write on an expression something like this, which is a script tag which initiates JavaScript here, where I've written this ellipsis, and you would end it like this, script, and say that in the middle of this code you have var myString equals, and you would now have a string, so quote, single quote, and it ends here with a single quote, semicolon, and some more code. If you were to have this, then this string you are expecting to be a JavaScript string, not HTML itself. So you would encode it with something different, which is encode JavaScript. This is how you would solve this issue here. This is why there are two different functions to encode your strings on an expression, depending on exactly what are you doing. Now, if inside one of your actions, let's open an action here, you have an advanced SQL node, then on this advanced SQL node you can have parameters, obviously. And each parameter has this option, expand inline. By default it's no, and therefore it's safe. However, say for instance that you want this parameter to include part of your SQL code. Say for instance that it includes the sorting option of your SQL. So it would include a column name followed by ask for ascending and desk for descending. This is SQL code. And then you would want it to be expanded inline, which is how we describe such parameters that are supposed to contain SQL code. If your parameter includes SQL code, then when calling your SQL node, you should assign a variable that you're going to give to your input parameter as, for instance, my column ask. This would be ascending. If by any chance the column name comes from an external source, or instead of a column name, if this is a where statement, because column names actually are not column names are not strings themselves, you would use encode SQL and the name of your my var that comes from an external source. You would assign this to the parameter, to the variable, which you will then use as an input argument here on the SQL node. And of course, when setting up your own URL, if you have, let's go back to our to-dos detail, we're going to enclose this on a link to, and another destination, external URL. Here we go, we have a link, and the URL is here, and we can say, okay, this is http://www.google.com query equals, and then you're adding something that comes from an external source. Because this is a query component, to be sure that this doesn't include an actual slash or another question mark or other symbols that confuse the actual syntax of a URL and can have some side effects on your application, you should use, of course, encode URL over your string that is being used as a URL parameter. This function, encode URL, just like encode SQL and all the others, they change the special characters in that context. So here, special characters in URLs, and on the previous example of the SQL, special characters in SQL syntax, they change the special characters there onto special sequences which neutralize those special characters and make them not special at all, but simply representing themselves on a string. And therefore, you are safe using these inputs on your code. And this allows you to have code injection prevention. But as you've seen, on the vast majority of situations, you need to explicitly open up the protections that the platform gives you. By default, the platform has these protections automatic, and any attempts at code injection are not at all possible. Another feature is data encryption. All secret keys and passwords that are stored by the application should be encrypted, as well as any sensitive business information. Now, the platform provides you with automatic encryption of some sensitive data on your database. But the only sensitive data that is encrypted is users' passwords. So the default users application already uses hashing encryption on users' passwords, as is the common practice and best practice in the IT community. Everything else that you may find that is extremely sensitive and should be encrypted before being stored on your entities or on your files in the file system, then you should encrypt manually yourself. However, remember that if you are encrypting any attribute on your entities, you can no longer use it as a filter on aggregates, because it is no longer understandable and readable by your database. The database itself reads the data as being gibberish, garbage to it. So if you're encrypting customer names, for instance, you can no longer find a customer that has a name that includes John. So using a search filter, which is like percentage, followed by the name that you've typed, followed by percentage, which is the common filter that you'd use on an aggregate to find something, won't work if that field is encrypted, because the database itself needs to look at those fields and understand them, search them against the string that you've placed on the query, and it tries to do that with encrypted information, so it won't find anything. It's not that it doesn't work in terms of failing with an error, it's just that the database will not find your information. So there needs to be some balance between what's encrypted and how do you want to use your information. Furthermore, it depends what are you protecting? What are you protecting against? Encrypting information that is stored on a database is preventing a database administrator from being able to read everything that is on your database. They can always read everything, but if you encrypt some information, they will not be able to understand some of your information. That's the only difference, as usual, in terms of encryption. However, anyone having access to the actual platform and being able to deploy applications and modules can create a tiny application that reads data from your entities and decrypts it and shows it on the browser screen. If one of your applications has access to the password that's being used to encrypt and decrypt information, then usually all your applications have access to that password. So now you need to find a way to store your passwords confidentially from one application to the next. This is not a trivial problem. It's not an OutSystems problem. You would solve it in OutSystems as you would on any other platform. And usually there is no good solution here. You may try to split this using a file which stores that password, and only the team that can manage a set of applications has access, physical access to that file. So only a few applications can do this in their own world, but it doesn't mean this only protects a team from stealing somebody else's, from some other team's data. It doesn't prevent somebody from within the team to do what I just said, which is to create a module which, because it has access to that file, can decrypt information and show it on screen. Also, your users who are using the information, regardless of how and where your information is encrypted, need to be able to see the information. They can't see gibberish. They need to be able to understand the information if, according to your business rules, they're supposed to. This means that it's far easier to find somebody who has access to the information and either try to steal their passwords with a phishing email or try to coerce them into showing you information, then it is typically to attack these systems internally. So again, depending on the sensitivity of the information that you're trying to encrypt and how difficult you want to make it for a hacker or somebody from your internal corporation to try and steal information, this can be an extra layer of security or not. But if it is interesting, if it is useful, it's there, it's available in the OutSystems platform. There are two main mechanisms available: one-way encryption, and this is available in the built-in user module function, encrypt password, and two-way data encryption, which is available in the Crypto API Forge component. Now, these are the two main types of encryption available in the IT world: one-way encryption and two-way data encryption. Now, usually when you think about encryption, this is the easiest one to understand. There is a key, which is a sequence of characters and numbers, which is used to encrypt data, and then you use the same key with the reverse function, which decrypts data. This is why you would need to have that key stored on a secret place somewhere, because that key opens everything. Now, this encryption can be harder to understand. One-way encryption is something that doesn't need a key. It takes your data, encrypts it, and there is no way to decrypt it. And that is actually the goal of these functions that do this. They are called hashing functions or hash functions. Their goal is to be impossible to decrypt data. And there's many reasons for this. They always return the same length as a result. They don't, for instance, if you have a 5 kilobyte file, they do not return a 5 kilobyte result. If you have a 1 byte file, they do not return a 1 byte result. They always return an 8 byte result. They are usually measured in bits. Typically, the old functions return 32-bit result. Current functions are more robust and they return 256-bit result. They always return this bigger result regardless of how big or short your source was. So what are they good for? If you can't recover information, what are they good for? Typically, the major use case is for passwords or something equivalent to passwords. When a user is created and you type in his initial password, or when the user changes his password, so when a password is set on the database, this function is run, and what is stored on the database is the result of the hashing function, which has nothing to do with your original password. What's the advantage? If your users use the same password for both your company and their Facebook and their LinkedIn and their bank, your database administrators or whoever else has physical access to the servers, even though they can see everything that's on your database, they won't understand the password, and they therefore can't steal those users' Facebook, LinkedIn, or worse, bank account. Now, if the password is encrypted, how do you check it? It's very simple. Every time this user tries to log in, the system repeats exactly the same function, which returns, hopefully, exactly the same result that's stored on the database if the password that the user is typing is the same as previously. And that's how the systems check. This is the best practice. That's how all operating systems store their users' passwords internally. They do not know your passwords. OutSystems also does not know users' passwords, but they can check whether a user is currently typing the correct password. This is how this works. Even though these functions don't require a a key, typically they insert something which helps make the resulting hash different from one server to the next, so that a database administrator or somebody who has access to the entities can't even figure out if the user is using the same password for system A and for system B, because the hash would be the exact same on both. This is called a salt on these encryption functions, but explaining them further is beyond the scope of this masterclass. So depending on your needs, you have this default function in the users module. You also have more one-way functions, crypto functions in this crypto API component. This is a supported Forge component which you can use in your own applications and provides multiple industry standard encryption functions. You also have your internal network. Back office applications shouldn't be accessible by front office users. Use internal network to restrict their access to a network IP, set, or range. Now, that's all that internal network is. You go over to the configuration tool of the OutSystems platform setup, and on your configuration tool there is a network tab, and there you would set the IP address or addresses that cover your local IP ranges for your network. There are 3 at least ranges that are IP address ranges that are reserved by the standards body that defines how IPs are distributed, which is IANA, International Assigned Numbers Authority. And you can use any of those in your network, and you need to specify them here on this place on your configuration tool. If you actually have a cloud instead of an on-premises installation, you can add support to set up firewall rules that will make the platform work in a similar fashion. Once this is set, whenever you set internal access only on your flows, then only those screens on those, actually then those screens on those flows can only be accessed from your internal network. Now let's take a quick look. So we have here a screen. As you can see, if I click on the screen to see its properties, I do not find an internal network on the actual screen, but I do find it on the flow, internal access only. I say that to yes, and this will only be accessible by the users on your internal network. Now, Service Center is automatically protected in this fashion. You can also set any flows, as I've said, to be protected in this fashion. But the use case for this kind of protection is not as large as you may initially think. Even though it's interesting to allow for your internal applications to only be accessible from your own internal premises, from your offices, that prevents your users from using them from the outside world. If in your company or in the customer that you're developing these applications for can have a use case where his employees should be able to use the applications from outside the premises, you can't protect that flow using internal access only. And it's very easy to find such use cases. If you have salespeople who need to use applications, they need to be on the customer with those applications. If you have mobile accessible applications that need to be used from outside your Wi-Fi, again, you need to be able to not set this internal access only. If you want your employees to be able to work from home because they have some issue at home or they're sick, then you can't have internal access only. So you really need to measure flexibility of your workforce versus security. But Service Center is one example of something that can be protected and makes sense to be protected and only accessible from the internal network. Another thing to consider is that if you do have a VPN available for your users, for their mobile phones and for their computers, then when users are outside your premises, once they connect to the VPN, they seem to be, from the point of view of internal network, they seem to come from the internal network itself. And in those circumstances, this will work as expected. Again, it's just a matter of how complex do you want this to be for your users, how sensitive is all of this information. So again, at design time, you set web flows and web services, a property that says internal access only, and at runtime, during installation, you have the configuration tool that sets this, or you can ask support for this to be activated for you. Selective deployment is another feature, security feature of the platform. The selective deployment of applications aligned with network segmentation is the best approach to segment your applications per user class. How does this work? Well, this works by, first of all, having more than one front-end server. Selective deployment is a feature that allows you to select to which front-end servers you deploy your applications. Say you have 5 servers, as in this illustration here. You may have wanted to have 2 servers for your public website, 1 server for your partner portal, and 2 servers again for your internal network, all of them on the same environment. You can do this by creating zones in the OutSystems environment, in Service Center. Zones are simply groups of front-end servers. And once you create them, you're able to specify for each application, for each module, onto which zone should it go. So here you'd have 3 zones. One for public web, one for the partner portal, and one for your intranet. Now, of course, now that you have this, you can't have a single load balancer. Once you have 2 or more front-end servers, you need a load balancer to split the load of requests between them. But if you have 3 separate zones, you need 3 separate load balancers. And why is this? Because you can't have a request for the public website to be sent here by the load balancer, and the second request to be sent here by the load balancer. You can't have that, obviously, because the public website isn't loaded here. So you need one load balancer for this zone, another one for this zone. In this case, it's a single server. You can do without the load balancer. And another load balancer for this zone here. Once you have 3 different load balancers, you need to find a way that people looking for the website reach this load balancer. People looking for the partner portal reach this load balancer or this server directly. And people looking for the internal network reach this load balancer. Now, this can be done with different DNS name, domain name service names. And we're going to see that in our case study, how is that applied. But that becomes something that is beyond the OutSystems platform itself, just like the load balancers. Load balancers are not something that belongs to the OutSystems platform and the OutSystems environment. It's something that you configure outside the platform, is part of any server farm setup, as well as external firewalls and DNS settings as well. So you can do this, but it becomes something that is beyond the platform itself. The platform simply allows you to have in the same single environment sets of front-end servers that belong to a zone and therefore belong to a group where some applications are deployed. Finally, we have the last feature of the OutSystems platform for security, which are roles. Now, very quickly, before explaining roles, we need to explain users and groups. Now, they are both set up in the built-in users application, even though you can set up your own. Users are obvious, they represent people, typically. Groups are simply sets of users and nothing more. And you grant roles either to users or groups, but preferably to groups, because it's easier to organize. So if you have a group, which is the human resources department in your company, it's much easier whenever a new person is hired for the human resources team, or when somebody leaves the human resources team and goes to the engineering team to change the group that they belong to. So you have a new user, which is the John user, who's been hired for human resources. You assign them to the human resources group, and you don't even worry about roles, because roles are set to the group. Same thing, if John moves from human resources to engineering, you remove him from the human resources group and you assign him to the engineering group. And you again don't worry about roles, because roles are assigned to groups. That is the only reason why groups exist, to make it easier for you to set permissions, which in the OutSystems platform are identified as roles. Okay, so what are roles then? Well, you set roles in your in the Logic tab of Service Studio. You can create roles. Let's go over here, Logic tab, we have our roles, and we can create new roles. Just add role, and now it's named role 1. I can use this, so human resources. So this is the human resources role, and it's defined here, and the properties for this are just a name, a description, whether it's public, so it's usable by other modules, and is persistent attribute, which has to do with dynamically assigning roles to somebody. So we won't go into this in much detail now. And nothing else is specified on a role. Roles do have this triangle here, and when I open it, I simply have automatic actions. The most important one is this one, that checks whether the current logged in user has a specific role, so I give it a specific user ID as a parameter, and it returns me a boolean which says whether this role is present or not. Then I can grant and revoke dynamically roles to users. So what else? How can I define what does this role mean? A human resources role means that somebody is from human resources. I can even fine-tune this. I can change this human resources manager. And I can then have human resources secretary, human resources this and that. So these are roles which typically mimic the names of roles that people have when they belong to a company. How can I explain what does this role entail? What does it do? What does it allow people to do or see? Let's go back here and understand this in steps. Let's take an example. On our PCs, if I can't read a file, let's say I don't have the read role. If I can't write a file, I don't have the write role. So there are names which describe our roles. And as we've seen on the platform, we simply set the name. That's really the only thing that we do. But then something happens with relation to that role. On our OutSystems application, we create our own roles in the Logic tab. And in the users application, we assign these roles to users and to groups. And then we check them in screens and actions. And this is what gives meaning to a role. This is the key. It's by checking the roles in your screens and in your actions that you make a role come alive and have specific semantics, specific meaning. Which screens should you check them in? Whatever screens are relative for that role, are relevant for that role. And for all screens that only authenticated users should access, you should always remove the anonymous role, obviously. But when you're trying to assign roles to screens, you just try to assign the screens that are relevant for your role. That may mean more screens than are obvious. If I go back to this example and I have a human resources manager, and I actually can be assigning, of course, the human resources application all screens to this role, but maybe a human resources manager can also manage other things in the company, and maybe anyone who is logged in can access the directory, the vacations app, and so forth. So there are many things you can that you should do in terms of assigning roles to your code when you're checking it, when you're checking these roles for actual semantics that are required to make people's work possible. So We should use roles for screens validation, also on BPT for human activity access validation. And these roles should be checked also to limit functionality or data access within our application logic. Users should only access screens, functionality, and data they're meant to. This is basically the premise of the initial user request or your client request in terms of what should security entail that I've shown you at the beginning of this masterclass. Users should only see or do things they're supposed to. You eventually create a grid which on your columns you can have screens and actions, and on your rows you can have roles, and then you check those connections that make sense. So who can do what? And with such a grid, with such a table, you can easily understand who can do what. Your customer can also visually understand who can do what and give the okay for that security model, and you can apply it then on the screens. A quick terminology check. Access control. Access control is determining who can do what. Who meaning users and roles from a business standpoint, and what is to see screens, trigger actions, and so forth. This is access control. And for access control, we need two things that have very similar names but are very different. Authentication, which is checking authenticity. Checking a user is who he claims to be. That is why, obviously, on a login screen, you don't only have your username. If people could be trusted, blindly trusted, that's the only field that was required. You just type in who you are. Please let us know who you are, and you type in your name, John, and that's it. Of course, people can pretend to be somebody else. We don't want that, and therefore we have a user and password. That is one form authentication. Some other forms are, for instance, checking that a user is where he can make such claims. For instance, the internal network configuration that we have available on the platform. Only users on the internal network can claim to be an employee of your company. And all these features are built into the platform and further specified by yourself. Authorization is authorizing something. It's checking whether a user who you now have authenticated by this time, by this moment, and you know he is who he claims to be, and whether this user can do what he is trying to do. Again, you specify this yourself on the platform. You create and set roles in application modules using Service Studio. We've seen this on the short demo that I've shown you using the Logic tab. But also in the screens then, you set these roles, you check the ones which are the ones who can access those screens and the actions of those screens just by checking them here. So every time you create a new role, a new row will show up here with the role showing up for you to check. And of course, or other screens, you can have separate or different configurations. Take a look at this example here because we're going to see it on the next slide. We have a home, a customers list screen where a partner manager and a partner user can both access the list of customers. But then in the customer detail, only the manager can access that application, that screen. So we can have a problem, and this is one of additional warnings that we have here interspaced in this presentation because security is not a closed field at all, and all security items that you should pay attention to is not only the list that we are showing you here. These are the major ones, but security, again, is not a closed subject in any application. You can have specific security requirements in your particular applications that only you can determine. And this is one typical example of how things can go wrong. This is called information leakage. Now, in the previous slide, you saw how a partner user can access and see the customer search screen, but it cannot see the customer detail. But a few months later, you decide to improve the usability of your customer's list screen. And you implement an autocomplete on your search screen. Even before the user types enter, while he's typing the names of your customers, they are being listed on the dropdown. And this is great to find customers. Now, previously, the customer's search screen and list screen only listed customer names. Let us pretend that. So a partner user could see customer names, but that's it. He cannot go into the customer detail and see further information. However, in your autocomplete, a few months later, you realize, hey, sometimes when we are listing in the autocomplete this information, there are two people that have the same name. How can we tell them apart? Oh, I know. We will show the client name along with the birth date. It's very unlikely to have two people with the same name and the same birth date as customers, and therefore this will be enough, should be enough, to tell them apart on the vast majority of situations. Problem is now that the user with the partner user role can see more information than he previously did. He can see client birth dates. And the platform can't figure this one out for you. It can't understand that this was a problem, and it can't protect you. This has become information leakage. You unintentionally are showing more information than you originally intended on specific screens. How can you solve this? Using your own analysis. This is not something that the platform can do for you on your own. This is simply a warning we have here on this masterclass. Be careful that the Alsystems platform doesn't hold your hand in terms of security from beginning to end. It can't. Not the Alsystems platform or any other computing system. Security is an open field. There are always new vulnerabilities and new ways of getting into systems that are being found out. You need to follow carefully the best security practices and the potential security breaches that you find on your systems, and pay attention to those by investing as much time as it is adequate on your application. So, coming back to roles, how do we grant roles? You grant them by configuring them in your user provider, which is the user's application, and then assigning them in runtime using the built-in actions, which you can also do with the grant role and revoke role actions that we've seen previously, which are automatically created for your roles that you create. You also build logic around roles, and this again is to give them semantics. The semantics that you give your roles, the meaning, is not limited to being able to access certain screens. You can then define further details depending on the current role. And you do this by showing some information or not, using an if block, an if widget on your screens. You use the check, whichever role you have, you want to check as your condition, and then setting different results depending on the current role. This could be in the partner manager. The partner user can't see the detail and therefore he shouldn't have a link at all. This is a usability thing around a security thing. And of course, in your actions, if more than one user can access your actions, say you have a button rather than a link to do something on your partner list screen, you need to check whether the current role is the partner manager, because he's the only one who can go into the detail and perhaps do some things in your screen. When you have more than one role on a screen, there is a likelihood that you may want to fine-tune things in your actions using this kind of node or statement in your actions. And this is it. These are the features. Let's see them applied to our case study. Now, we begin with no network segmentation, the applications for the internet users, which is the public website, and the partners, which is the mywebsite.com/partner portal, are accessible to anyone on the internet. And even the intranet application, which should be only for corporate users because it has a normal address, currently there are no firewalls, no users, no nothing, can be accessed publicly. So this is completely unprotected. Let's start applying the best practices to protect our user, our company. First of all, we set the internal network for the IP range that you're using on the internal corporate network. The advantage? Well, suddenly our friend, the hacker, Joe Hacker, can no longer access any application because he can't access the intranet. I went back one slide. This application, we set its flow to be only accessible by corporate users and therefore only usable from within our premises or via VPN. So this application he can no longer access. Furthermore, systems applications such as Service Center are now protected also and can only be accessed from within our premises. But we still have problems. Partner portal can be accessed by anyone, including the hacker, and all users have the same actions. We're going to see how to fix that in a second. Before we do this, just one word of warning. If we are protecting Service Center as being accessible only from within our premises, in order for this to be anything relevant, there are two things that you need to do. First of all, obvious, non-IT related, you need to have some sort of control about who gets into your premises. If you have an open workshop where customers and anyone from the street can get in, and if there's enough people in your workshop that not all employees know one another, it's very easy for a hacker to just waltz in and connect a computer to your internal network and do whatever he wants. So this only works if you have physical protection, of course, about people who are not your employees accessing your network. Not only that, but remember that your Wi-Fi is part of your internal network, and your Wi-Fi will likely leak a few meters, a few feet outside your premises. Remember to set a password for your Wi-Fi. Remember to make sure your employees don't share that password with anyone. Otherwise, it's as easy as somebody sitting on the street with a laptop just close to your premises, and they can do whatever they want. They pretend to be part of your internal network. Or if there's a local coffee shop, they can just sit there much more discreetly and also be able to do whatever they want, because they'll likely be able to access your Wi-Fi. So internal access only is only a protection as long as you do further steps to protect your own internal network. Furthermore, let's use selective deployment to separate our applications through several front-end servers. Now, in order to do this, instead of one front-end server, we're going to have three. One for the website, one for the portal, and one for the internal corporate network. Now, there's no need for load balancers. There would be one load balancer here, one here, and one here. So no need for load balancers. However, like I said, while presenting this part of selective deployment, we do need to find a way to identify these servers / load balancers from the outside world, so that when the user types in a URL, he goes here rather than elsewhere. And that is done with different domain names. So for the public website, you would still use www.mywebsite.com. But for a partner portal, you can now use something like partners.mywebsite.com. And for the internal network, you can use intranet.mywebsite.com. So now the /something has gone away, and the domain name itself states which is the major entry point into your application world that you want to use. The advantage of using separate domain names is that technically each DNS domain name, as shown here, is converted onto a different IP number. So when a user types in this, he gets directed to this computer that has a specific IP number. When the user types this, he gets directed onto this computer that has a different IP number. And again, here. Okay? And even this actual name could be a domain name system, a DNS address that is only available within your network. This could even not be configured for the outside world. It's only understood by local computers that use a local DNS server, like on every network. And that local DNS server has one added rule which defines this particular address and sets it to a local network IP address. All that makes sure that this server here is invisible from the outside world. Again, these are configurations which are outside the scope of the OutSystems platform itself. They are configured using whichever partners you have for your domain name registration, and also internally whoever manages your local network. These are the technicians who can do the actual configurations to set this up. On the platform, you set up the 3 front-end servers, the zones, 1 zone per server, and when you do that, you can now select whenever you publish an application, a module, to which zone should that module go. So your intranet application should go here, your partner portal here, and your website here. This makes sure that anyone accessing this URL, this IP, can try all the combinations they want of /something, but they can never find anything sensitive because it's just not there at all. Same thing applies here, partners /something. They can only find partner application content and nothing else. And the same thing here, even though this is now less relevant as it's in the internal network. Your internal users can do /something but they can only find internet application stuff here. How can you prevent now your users from the cloud from accessing this internet? Well, first of all, we already had the internal network configured here. But even if we hadn't, now that we have different IP numbers for each server, we can set up a hardware or software firewall from the outside world to our servers that filters access. These rules will say that this IP is not accessible from the outside world, but these two are, hence this yellow background here. So again, this is outside the OutSystems platform world. This is something from your hardware firewalls that access the environment where the OutSystems platform is installed, and you would only allow access to these two IPs from the outside world. Finally, how can we make sure that only partners can access this URL? Well, you can only do that if your partners have static IP addresses from their outside world, so to speak. From the point of view of the internet itself, from the outside world, do those partners have fixed IPs? If they do, you can set up rules. Every time a new partner registers, he should give the outside world IP or IPs that they use, and you can set then firewall rules that only allow those IPs onto this partner portal. And if you do that, then you have your partner portal protected, and only partners and whoever works with inside the premises of those partners can access your partner portal. And this means that our friend Joe Hacker can no longer access the partner portal. So selective deployment is what opens up the possibility of doing these configurations which are beyond the OutSystems platform. DNS configuration and firewall configuration. But still, all users access the same screens and execute the same actions. So on the intranet application, everyone, human resources, engineering, etc., sees the same things and can do the same things. And every partner, regardless of who they are, can see the same price lists, purchased items, orders, and so forth. And how do we filter that? Obviously, we simply create roles for each of these. So we create a partner user maybe and a partner manager. This is relevant for our business. And these applications, the partner portal application, all screens or flows can only be accessed by these roles. And you can even select one or the other depending on the sensitivity of each screen, as we've seen. The public website can be accessed by anyone without any logging in, so we just set the anonymous role there. And on the internal network, we can allow anyone who has a username and password to access this internal application. This is the automatic registered role. The registered role, let me show you, is automatic. It's grayed out here. Anonymous and registered are grayed out because you can't delete them. And the anonymous means anyone without logging in, and the registered is the opposite. Anyone as long as they have logged in. And on this simple example, anyone who has a username and password can access all screens on the intranet. On a real example, you would create roles such as human resources, engineering, and sales, and so forth for the multiple areas of your internet application. And now finally, all case study problems have been solved. And your application, your customer is now provided with some basic important security on its application. Some additional tips. Don't use client-side code to secure objects. So here we have a screen and we're using the enabled property to disable the button, a specific button or an input item based on a role. Now this is bad. We're going to see what is the good idea. The best practice would be to use an if block to decide whether or not there is that role, and if there is a role, you specify an input because it can be changed. If the role is not present, you simply display the current value and don't allow the input to be there at all. You could also use the visible property on the input, but there is no visible property on text. So this is the best practice, to use a decision widget, an if widget, to decide what to display. This widget runs on the server, and this means that what is transmitted to the browser is only the input or only the text. Whereas with this option here, the input is always transmitted and the browser is given a hint not to allow the user to type onto that input. However, a hacker or an advanced user can look at the source code, understand how it should look like if it was not disabled, and even if the user has developer skills, he can very easily at runtime re-enable the input and therefore make the request to the server. So, first good practice, don't use client-side code to secure objects. But also remember that you need to double check these things on the server side itself with this kind of action. When you have an action, which is the submit for this form or something else, you need to double check your roles, because it's very easy in the browser to fake requests. Even if you don't send this input, if some user has seen anyone with a screen where the input is present and could quickly look into the code and see how is it named when it's being sent to the server, they can fake a request. And the server can't tell whether this was available initially when sent to the client, to the browser, or not. The only way to be sure is to do your own checks using this particular action on your own screen action. Always double check roles on your own screen actions. Remember also to use login and HTTPS on web services. Now, web services are sources of information which you provide to the outside world. Remember to double check that whoever is accessing them can access them. The login procedure for web services is not the same as for a screen. You don't have a user interface, so you need to find your own login procedure for a web service. And this can be as simple as internal network only, if the web service is for internal consumption only, for some other modules of yours. And remember, of course, to use HTTPS. There is no reason not to be using HTTPS on every single screen that you have nowadays. If you think about it, nowadays, if you go into Facebook and are looking at a cat video, look at the web address. You are using HTTPS. Facebook has redirected you over to SSL just to ensure that you have your privacy, even though you're doing something as innocuous as looking at a cat video. The same thing applies to Google. You're searching for a recipe on how to cook beef. Very simple, very peaceful, very innocuous thing to do. Look at the web address. You have actually been redirected to HTTPS for security, for privacy. You are entitled to your privacy. And if even these basic services provide you with privacy, professional web business applications and services should be protected with privacy. Remember to set this on every single screen, but also on your web services. They are very old protocols. They are supported by every single smartphone, computer in existence. There are some extremely rare exceptions for some very old systems that would need to have something like 20 years old or in that vicinity in order for them not to support SSL. So they are very old systems, very old standards. Everybody's supporting them. You should support them as well. And that is it for our masterclass. I hope you have enjoyed it. Thank you for joining me.